farm boundary extraction using Earth observation data and segmentation. So firstly, for disclaimer, this project is still ongoing. So maybe I just want to share like a preliminary research result from this project. So maybe if you guys have any suggestion or feedback that I can improve for this project, it will be really useful for me. So basically, this project is my internship project under the supervision of a great mentor from SERVIR that are Aparna and Biplav. And the main objective of this project is I want to apply like deep learning based model for automatic field boundary extraction using satellite imagery data. So hopefully from this project, we can accelerate the process of providing the spatial information data for the agriculture and other food security project that's starting from extracting the field boundary. So there are several challenges that we are working with farm boundary extraction. So the first one is due to like a different and complex form of the farm boundaries. It's also giving a challenge. So every place or maybe like different geographic area or different study area will have like different form of a boundary. So if we train a model in like specific area, we cannot like directly use that model to the other area. So that is the first challenge. And the other challenge is also related to the reference data itself. So most of the area that are have like an agriculture area, they're only limited or even unavailable farm boundary reference data. But in other hands, if we trying to develop a deep learning models, we need a huge set of reference data, which is farm boundary itself. So this is kind of a contradictory. So we need to find a solution for this condition. And also, if we are working with small farm boundary delineation, we need to use like the high resolution imagery data that can capture or can detect even a small farm boundary. As a solution for the challenge that I mentioned before, so I propose a workflow that I hope this workflow can be useful and can be as a like a template workflow if you want to do like farm boundary extraction and apply in a different study area for specific for other future SERVIR projects. So the first is I'm trying to utilize pre-trained farm boundary delineation models that already trained from different area. So some of model are already trained in some of different area, like in Netherlands itself. We already have those kind of models, or also in Paris and other in France and other area as well. And using that pre-trained farm boundary model, we can do like the transfer learning. So we can provide some reference data in our specific study area, and then we apply a transfer learning using a pre-trained model that we already have. And the last part is we can do the validation to see how this model works, or to see the performance of the models. And yeah, to start with that workflow that I propose in this project, I will working with a study case in Kenya. So as we know that Kenya is also one of the focus area of a SERVIR. So we know that in Kenya the form of the farm is relatively various. So we have like quite a large area, and also we have like small farm. So this is kind of a unique condition. So we need to train a model that can be able to capture and also delineate the farm boundary, both of like the small and also the big area of the farm. So yeah, that's this is the study case that I'm working on. So mainly this project will consist of 4 phases. So I'm still working on that. So this project is not finished yet. So the first thing that I did, which is the first phase, is I'm trying to do the data collection and preparation for a target study area, which is I'm working with Kenya data. So for data collection itself, so I choose like one focus area in Kenya, which is one of a specific county in Kenya, and then I divided the area into 256 by 256 pixel grid, and I will use like that details to train validation and test as a train validation and test data. And I will use like Sentinel to image data because of it's publicly available and also have like enough resolution. And due to the unavailability of the farm boundary reference data in Kenya, so the thing is I need to do like manual digitation to provide the farm boundary reference that I will use for my deep learning model. So this is what I did. So this is the area in Tanzania in Kenya. So I divided, I generate tiles with this size, and then I download a Sentinel image based on the tiles. And the next step is I did some manual digitation for the farm itself. And by this, I able to provide the reference image, which is the left one, and also the boundary mass files that will be used as the training test and validation data for the deep learning. Yeah, and then after that, for the second phases, I'm going to find pre-trained models that it's already available, and they also provide like the data that I can use, because as I said before that we need we want to build deep learning, we need like a huge set of data. So for the second phase, I'm trying to like find from the literature from the previous work that working on the same topics. So I found like this 3 available data and pre-trained model from 3 different areas. So the first one is study case in Netherlands, and then also Rwanda and India. And after I got like the pre-trained model, so I'm going to choose one of the study area that quite similar with my study area, which is Kenya, to do some exploration. So I try to build a model from the previous project, which is I choose Rwanda. So this project basically from the NASA SERVIR. So they have like dataset for wonderful boundary competition dataset. So they provide the dataset from PlanetScope image and also the reference data for the farm boundary itself. So they also provide like 70 tiles covering more than 1,000 individual fields. So I will use this data as like a pre-trained model. So I need to train the model using the Rwanda data itself. So this is the example of the Rwanda data that's already publicly available. So this is the image and also the mass. So yeah, I'm using the UNet model. So I trained the model using backbone from ResNet 34 with pre-trained weight from with pre-trained on ImageNet, and then this also the training settings. So actually, I used the default training setting from the NASA Harvard documentation. So because of this is only like the first phase of my project, so I just want to like see like the default result from this documentation and see how I can improve from this like start. And then after I train, like using the default configuration from the NASA Harvest documentation, so I got this kind of result. If we compare like the training and validation loss, we see that the model shows to be overfitted, and this can be happen because of like the training set itself. We know that Rwanda dataset they have like a partial mass levels, so they didn't give like the full mass level. So I think that's why also uh, source of the overfitting that happen. And another like source of why this can happen also maybe also the configuration. So maybe I can do some experimental that I can improve and also avoid the overfittings. And if we see the result from the default configuration, the result is not really that good because the model is not able to capture the boundary clearly. They only capture like partial line of the boundary itself. So this is the like the result from the Rwanda data. And I also try to see what this model perform in Kenya data. So previously, I already download Kenya from Sentinel Imagery. I try to put the Britain network from Rwanda to Kenya image, and they give this result. So basically, it's quite similar with the Rwanda result itself. It can the model still cannot capture all of the boundary really good. So I think there will be some improvement or some experimental that I will apply to improve the model itself. So yeah, there will be some of the experiment plans that I will apply to see that this configuration can improve the like the performance of the model or not. So maybe I will try to train the model from scratch. Like I said before, like we use pre-trained backbone that train in on the ImageNet data. So maybe if I try to train the model from scratch, it will give like another result because like we know that ImageNet data they only consist of 3 bands like RGB only, but from our data we have like a near infrared band. So maybe it will give like some like improvement if we try to train the model from scratch. And also, I will try to do like fine tune for the model hyperparameter, like changing the bed size, epoch, and optimizer. And also maybe I will try to compare the model performance with and without applying augmentation techniques. And maybe this will give any improvement for the model's performance. And also for the Rwanda case, they provide like spatio-temporal data. So they provide like 6 month different temporal data. So I will try to like compare if I use like only one time data and also like spatio-temporal, it will give any different or not. And also maybe I also will try to apply some of the remote sensing indices that I can provide, like such as NDVI and like soil indices and etc. And yeah, maybe after I got a good result for the like pre-trained models, which is in Rwanda. The next things that I gonna do is I will transfer learning the models into the selected study area, which is Kenya. So yeah. I think that's all from me. So, like I said before, I really appreciate if you guys have like any comments or feedback or even suggestion that will improve or maybe give some of tips that I can apply for this to finish this project. Okay, that's all from me. I will give the screen back to Biplav. Thank you.
Thanks, Ali, for this great presentation. I'll open the floor for any questions, anything from people.
I have some questions.
Yes, Artie, please.
Thanks so much for this presentation. It's really great work, and it's also much needed because this is exactly the type of models that we're also looking for. I was wondering for the results that you showed us, how many batches did you feed into your model?
Yeah, from the Rwanda dataset, we have like 70 tiles for the training data.
70,000.
Yeah, we have like 70 tiles.
Okay, that's a sizable amount. And the results that you showed, is that from the testing data set, or is it from the training data set?
The result is from the test data set.
Okay.
Yeah.
Yeah, because the results didn't look that great yet. If it's from the training data set and it looks like that, then there's usually something wrong. But if it's from the testing data set and the model hasn't seen the result, then that should be okay. And this was on 3 bands because you use transfer learning from ImageNet.
Yeah. Like I use the pre-trained weight from the ImageNet for the backbone itself.
Got it. And the training data set from Rwanda, that's provided including the satellite imagery for 3 bands?
Oh no, the training data set that provided is actually for bands. So it's planet scope image. So they have like RGB and near infrared.
Okay, and how do you train that for? Because ImageNet is 3 channels, right?
Yeah. That's why maybe I also like thinking it can be the source of error that make the model is not really well performed, because like the ImageNet was trained using like only RGB, but I give like the input for the 4 channels or 4 bands.
Got it. Okay.
Yeah, I think.
So you use RCPN, and just define 4 channels when you feed the data, and the rest of the network is populated with ImageNet weights. Okay, that makes sense.
Yeah, I think.
And for transfer learning, please go ahead, Biplav.
Yeah, just to add some more context on what he's doing. So I haven't like gone deep dive into the notebook that he's using, but that's one of the Harvest notebook from the NASA Harvest. The way they have done is they have a backbone of ResNet 34 that uses the ImageNet weight, but then so they have the planet scope image for before and after growing season. They don't have any image during the growing season, so they have image for 6 months in a year. Each of them has 4 bands, so they have like a 24 channels in total. Once they train the ResNet model, and on the final block, convolution block, they output 24 image 24 outputs, which is fed by those 24 image channels. So it's kind of I don't know how to interpret that. So I've asked him to just use 4 channels for now without using any ImageNet width. So yeah, it's I don't know, it's a different kind of way they have done it. They are giving the entire years of data as one go instead of giving monthly data, if that makes sense.
That makes sense, yeah. And it also looked from the results, well, we've only seen a few results, that there are some edge effects. Is it wall-to-wall coverage for the image patches that you're feeding?
I think there are some edges that are extracted out, like some boundaries would go in multiple tiles, and if the boundary is going in another tile that you don't have data, it's just chopped off on that. And probably that's one of the reason he's also getting a lot of those edge artifact in his model. Yeah, so there's a couple of suggestions that I told him in terms of just using a simple UNet with RGBN and providing in a year's worth of data, a simple model, just to see that we're on the right track before adding anything else or using the ImageNet width. Yeah, so we'll see how it goes.
That makes sense.
Yeah, if you have other suggestions, feel free.
I would increase the bed size. I think 4 is very small.
Yeah.
Oh yeah. Yes. Okay.
And I'm also wondering with the balancing of the data, because if you look at you basically binary data where the positive class is much smaller than the negative one.
Mm-hmm. Yeah, I guess the other way would be to convert those pixel values into some sort of a bounding box and do a object detection kind of thing. Yeah, but we are like very short on time, so.
And include early stopping in your model, because it's overfitting after, I think, 25 epochs.
Yeah.
How long does one epoch take to run?
Ali, you wanna?
Sorry. Sorry.
How long does it run to? How long does it take to run one epoch?
It's not really that long. Like I run 200 epochs and maybe it's only like an hour or something, because I only use small batch as well.
And
yeah,
he's using Google Colab, so
okay,
it runs fine on that.
With the GPU.
Yes.
What kind of GPU? What type of GPU do you get with Colab?
I use like from the default Google Colab GPU.
Okay, I'm not gonna steal more of your time. But this is great work. If you have some more results, then please stay on the presentation.
Yeah. Mm-hmm.
Hello.
Metal.
Yeah, we can hear you.
Yeah.
Okay, go on.
Okay. So please, have you tried another loss function, like the dice loss?
Sorry, can you repeat the question?
Have you tried another loss function, like the dice loss?
What do you mean with try with another
loss function?
File save or
another loss function?
Loss function.
Oh, loss function. Oh, okay. Yeah, actually, I didn't try any modification for a loss function. I only apply using binary cross entropy loss function. So I don't know if I need to like try another loss function, because this is only like binary classification, like a 1 for boundary and 0 for the background or non-boundary.
So most of the time, the dice loss concept is used in image segmentation.
Oh yeah.
Yeah, I think that's a really good point. We also did a study, but this is more on the surface water detection, also uses a binary classification approach. We tried out different loss function, and I think the BC dice loss or the BC loss was outperforming the binary cross entropy. So you might also want to try other loss functions.
Yeah, okay, yeah. Yeah, thank you for the suggestion.
So I had a super basic question only. You're trying to only detect the boundaries, right? This is not a segmentation problem.
Yeah, no, not the whole farm area, but only the boundary.
Only the boundaries. So the results that you showed looked very similar to, like, if you take a satellite image and pass like a Sobel or a Canny filter over it, would that be something you could do to pre-process before you actually put the images in there? Because that would already get the edges for you. That's what and this standard remote sensing, right? I mean, it's not machine learning really.
Yeah, true. Yeah, that's also what I thinking when I got the results. So, but I think because this is like only preliminary research that I didn't make any modification from the documentation from the NASA Harvest. So like such as like the what is like the data training that I put in the models and also some hyperparameter, etc. So that's why the result is just like edge filter or something, like we applying like simple filter to the image. But if we like check further to another documentation for the other previous project, such as the one that they working on the Netherlands data, they also use UNet, and they give like a more crisp boundary extraction. So it's give like a better results compared to like basic machine learning or basic filtering for the image analysis. I think that's what I'm trying to like to get from this project.
Makes sense. I mean, I was just thinking if there was a simpler way of doing this. You always go for simplicity, because we've done this in the past and I'm old, right? So we used to stack images, do a PCA, and then basically just do a one edge detection, and then basically clustering of the different PCA components, and that would usually find most of the not farms, like blocks that are distinct phenologically. And so when I looked at your problem statement, that's what I was thinking, because if you have the full phenology of the landscape with a stack of Sentinel images or something, you could probably just stack them up, do a PCA, get sort of like a phenoregion map, and then use a unit to classify all the fields. And then whatever's left over might be, the boundaries, if boundaries are exactly what you're looking for and not the fields.
Mm-hmm. Yeah, I think the idea why we try to use deep learning other than like basic machine learning or only filtering to the image, I think because of we need to different which one is field agriculture area or only like a basic field. So I think the the basic filtering technique, it's not able to differentiate that kind of things, right?
It's exactly, yeah. I mean, that's what I'm saying. If you take just say the entire year's worth of images, right? If you stack them up and do a PCA, what that does is it compresses all that, all the phenology of the field, basically. So if you have a forest, phenologically, that will look very different from a farmland, right? Because the farmland is completely bare and then goes green and then goes completely bare after harvest. And generally speaking, when you do the PCA, they all end up being differentiated across the entire scene. And so then it becomes very, very easy to pick them up. So you can then say, okay, this is completely, stuff that does not change spectrally, which is like, built up area and things like that. And other things that do change just a bit, like water bodies, in which they'll grow and, they'll expand and contract if it's clear, or they'll get muddy and then clean. And so they just all have their own patterns, which gets pretty, easy to distinguish once you get that PCA in place. And then it's basically, you can pick and choose which components you want to use as the 3 bands for the classification purpose. It's basically just pre-processing before you actually throw it into the machine learning model. Yeah. Different ways to skin this cat.
Thank you.
Yeah, thank you. That's a really good suggestion. Okay, any more questions on Ali's presentation?